Hi, grade 11s. This is the beginning of a section called Solution of Triangles or Trig Triangles. And this video is just going to cover the first rule, the sine rule. This section is so nice. You're going to love it. It's really, really, really nice. And just some background on it. You have worked with triangles before, Pythag, area of a triangle. So in a right angle triangle, you've worked with Pythag, finding a third side when you have two sides. You've worked with the area, half base times height of a right angle triangle. And last year and this year, you've worked with the trig ratios, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So we're going into now working with non-right angle triangles. And there are little rules and formulas to learn, but it is so great. So I hope you enjoy it. Right, so the first rule we're going to look at is called the sine rule. So this is a non-right angle triangle. You could use it in right angle triangles as well, but rather focus on some of the easier ones like Pythag. So this is where you are trying to find maybe an angle or a side. It depends on the information you've been given. So we will work through different examples and different scenarios, and then you can see when you'll be able to use this. So the rule is that in any triangle that you're working with, if you take the side that you're looking at and you put it over sine of the opposite angle, that will give you a ratio, a fraction, a number. Then if you take another side opposite to its angle, you use sine of the angle, then you will end up getting the same ratio. It will be equal. And then the third side across from its sine of its angle will also get you the same ratio. Now you could flip all the fractions and have the angles at the top. It doesn't matter where you position it, but I'm going to show you a little trick of where it's best. Okay, so you're not necessarily going to use all three sides, all three angles in every question. So let's have a look at an example, and then I can show you. Just make sure your calculators are on degrees mode. All right, so for question 1, it says solve for the unknown angles. So solving for unknown angles means we need to look for angle P and angle Q. So now what we need to start with, if we're going to use the sine rule, is we need a full pair of information. So a side and its opposite angle. So I have that in this respect. I've got angle R and I've got its opposite side. Let's see what else we've been given. We've also been given the side 6, which is opposite Q. So that's telling me I need to start with Q before I do P. Now with P, I won't necessarily need a side. Once I've got two angles in a triangle, I can work out the third using angles of a triangle, add up to 180. So I like to start with what I'm missing. So I'm looking first for the angle Q, because I've got its opposite side and I've got a full pair. Always need a full pair of information. So I'm going to start with saying sine Q over its opposite side. So I've put the angle at the top. So then I'm going to put the angle at the top on the other side. So we're working with sine 100 degrees over 11. So angles at the top, opposite sides at the bottom. Then how do I get sine Q by itself? I multiply the 6 across. And then in my calculator, once I've got sine angle equals a number, so this is representing a number there, and then I can say shift sign on my calculator. So it'll be sine -1 of this little yellow circle of this fraction. So I'm going to put it in quickly. All right, and just make sure you got enough brackets and your calculator knows what's going on. If you get a syntax error, which I just got on my calculator, it just means I left off a bracket or it was confused. So just make sure there's a bracket. For every open bracket, there's a closed bracket. So I get here that Q is 32,49 degrees. So then now I've got 100 degrees, I've got 32,49 degrees. So then I can use my angles of a triangle and I can work out angle P. So angle P must be equal to 180 minus 100 minus 32,49. Give your reason here is angles of triangle. And so 180 minus 100 minus 32.49 gives us 47,51 degrees. So there you've got your angle Q and you've got your angle P. Easy enough. So let's try another one. Different scenario. So it says solve for the lengths of the unknown sides. So what sides are unknown here? We've got MK and TK. So now to decide what are we going to start with first. In order to use the sine rule, we need a complete pair. So there's an angle and its opposite side. Then we look at what else do we have. We've got 96. So let's start with TK, its opposite side. So now I'm solving for TK first. So I'm going to start with TK over sine of 96 degrees. It's just better to put what you're solving for at the top left of your equation and then the complete pair on your right hand side. It's just easier to rearrange algebraically. So then what's my side that I've got here? I've got 9,5 across from sine 50 degrees. And then there's quick rearranging. If you don't put that TK at the top left, then sometimes the rearranging takes long. So 9,5 times by sine 96, because you just take it across, over sine 50 degrees. Pop that into your calculator and you'll get the answer. And I get 12,33 units. So then now we've got to work out the next side. Okay, so let's just fill in what we've got here. So we've got 12,33. Okay, so we've still got our complete side. Now we've got to work out MK, but we don't have its opposite angle. But don't forget your basic easy geometry of a triangle. You've got two angles, so we can work out that third angle straight away. So angle T there is going to be equal to 180 minus 96 minus 50 because of angles of a triangle, which gives us 34 degrees. So then now, what am I looking for? I'm looking for MK. What's its opposite angle? Sine 34. And then I'd prefer to use my original complete side. Don't use a previous answer in case it's wrong. So what's my side that I know? Because I've got sides at the top. I've got 9,5 over sine 50. Show me the rearranging, please. You get a mark for this. Sine 34 degrees equals, oh, sorry, I've left out my dividing, over sine 50. So I've just taken the sine 34 across, and then in your calculator, we get an answer of 6,93 units for our MK. Now, the numbers need to be realistic. You're working, if you look at the diagram that's been given, this is 9,5, which is quite a long side. Then this is a longer side, so it's 12,33. This is a shorter side, so it's the 6,93. If you suddenly get a weird answer in the 30s and it doesn't look like the longer side, then just go reevaluate your answers. Okay, let's do a couple of more examples. So for number 3, it says solve for the unknown angles. So we've got A and B that are unknown. First, for the sine rule, look for your complete pair. I've got 50 and I've got 9. Then look for the piece that you have the most information for. We've got a side, so we're going to work out angle A. So I'm going to start with sine A, because that's what I'm looking for, over 10 is equal to sine 50. Please make sure if your angles are at the top, they must stay at the top for both sides, over 9. So sine A is going to equal to sine 50 times 10. We take the 10 across, over 9. Pop it in your calculator. It's going to give you an answer, but you can go straight to saying shift sine in your calculator of that fraction. And I get 58,34 degrees. All right, so that's angle A done. So now we need angle B, but we don't have its opposite side. We don't have to worry about anything, so let's just use angles of a triangle. So angle B is equal to 180 minus 50 minus 58,34. Don't forget to tell us angles of a triangle. They probably wouldn't take off a mark, but you don't want to be penalized for something so small and so easy. Okay, so we now have 71,66 degrees. All right, so then solve for the lengths of the unknown sides. So it's kind of the same procedure each time. So we're going to look, here's our complete pair. We can start getting LK, and then we can find angle K using angles of a triangle and work out LN. So it doesn't really make a difference which one you start with. So let's start with getting LK, just because that's what I saw first. So LK is what I'm looking for. What's the angle across from it? Sine 33. And it's equal to 15, which is across from sine 48. So then LK is 15 times sine 33 all over sine 48. All right, so in your calculator, sine 33 times by 15, divide that all by sine 48. You can use a fraction or separate pieces, and I get 10,99 units. If they haven't given you centimeters, you don't have to give any form of unit there. And then I can work out angle K is going to be 180 minus 33 minus 48, angles of a triangle, and we're going to get 99 degrees. All right. So then we're going to work with, we want Ln. So Ln over its sine 99 is going to be equal to, I'd prefer to use the original given information, and then get Ln by itself by moving the sine 99 across. And here we don't need to use our shift because we're not solving for an angle. So you just type it in straight into your calculator in the fraction button, and we get 19,94 units. All right, so this is just an extra example. So, and it also gives you the scenario of when you would want to use the sine rule as opposed to the rules we're going to learn in later videos. So if we are given two angles in a triangle and the length of a side opposite to one of those angles, you can use the sine rule. Okay, so in this case, we're working with finding the length of side A. We've got its opposite angle, and we've got another angle and its opposite side here. So using the sine rule, you look at side A over the sine of its opposite angle. You look at the other side, 7, and sine of its opposite angle. Rearrange, put into your calculator, and don't forget 2 decimal places. All right, then the second scenario when you could use the sine rule is if you're given two lengths in a triangle and an angle opposite one of those lengths. You can then find an angle and then use angles of a triangle. So here they just want you to work out angle B. Angle B over there using the sine rule then, because it's got a complete pair and one opposite side. So they match up. So that when you're looking, you only have one thing missing from your double pair. So we have sine B over its opposite angle. Rearrange it and then shift sine because we're solving for an angle, and then 2 decimal places for your angle. We're going to come back to this example in the next video where it talks about the exceptions to the rules. So just have this one. I will show it again in the next video, but it's just something that is quite useful to know for the exceptions. All right, so in this case, this is the proof of the sine rule. You do need to know this. They can test it, but it's quite quick and easy. So if you were given a triangle ABC, so here you don't really see the original here. So ABC, or any letters, but you're given a random triangle, and then they ask you to prove the sine rule. You would first just label the opposite side. So that is little b because it's across from the angle B, little a. Don't worry about this side, but it is technically little c. But then we're going to drop a perpendicular. So it gets broken up anyway. And we're going to call that little point D there. All right, so we drop a perpendicular, make 2 right angle triangles. And then we're going to call this H for height, not for hypotenuse, and then we're going to do the following. So if we now look in this triangle, let's actually highlight it rather. So this triangle, if I looked for sine A, because we're trying to prove the sine rule, and this was just made up by mathematicians that just played around with things. So sine is opposite over hypotenuse in a right angle triangle. So now the h is not the hypotenuse, it's the height. B is the side across from the right angle, so it's the hypotenuse here. So it's h over b. Now, because we put in an h, that was something we constructed. We need to get it by itself so we can try and get rid of it. So we could multiply that b across and get h alone. Then if we look at the other side, right, the other right angle triangle, let's use green, there we go. We could do the same thing, but with sine b is going to be h over a, because h is the opposite, a is the hypotenuse because it's across from the right angle. So h over a, opposite over hypotenuse in the right triangle. Then rearrange it, we again get h by itself. But when you have two things that are equal to the same thing, so h equals b sine a and h also equals a sine b, then you can squish them together because they both equal h, so they must equal each other. Now that doesn't quite look like the sine rule, but it's nearly there. You can choose whether you want to get the sides by themselves or the angles, so let's see what's happening in the next slide. So in this case, so this is what was on the previous slide. If you divide both sides by sine A, okay, so imagine that happening, divide by sine A, those cancel, right? And so you'll be left with B equals A sine B over sine A. Then if you divide both sides by sine B, that would cancel and you get a sine B over here. So that's what you recognize as part of the sine rule. But say we had not dropped the perpendicular from C downwards. Let's say we dropped it from A. Then we could have used sine C and done the same thing and gotten the other piece. But if you notice, sine B and its side and sine B and its side are both equal to different fractions. So those different fractions must be equal to each other. So we say that they are all equal. Then if we flip all the fractions, they're still all equal to each other as long as they are all flipped. So this is for any generic triangle. You can work with the sine rule. So when you're doing the proof, you only have to prove 2 of the ratios. You don't need to do 3. You just show the method that I showed you, and then that's a good maybe 4 marks that you can get. All right, so when would you use the sine rule? Just in general here, 2 sides and 1 angle, but it's not at the included angle. So if you're given this, you have, let's say, 2, 4, you won't use it if it's got the included angle because that's opposite an unknown side. So you need a situation where you have 2 sides and then an angle opposite at least one of those sides. That angle must be opposite one of them. Or if you have 1 side and 2 angles, so let's say you have 2 there and you've got 50 degrees and 60 degrees, then you can always find your third angle using angles of a triangle. Here's your complete pair, and that you must have 1 complete pair always. Okay, so you would have a complete pair at all times. Right, so I hope that helps. And so in the next video, it's just the exception. It's called the ambiguous case, where sometimes some questions give you a bit of problems. But this is the sine rule, and now you can work through the notes that Mr. Gomes put up as well. I will put up a video on those notes, but this is just to get you started and get you introduced to the rule.